In this short video, we'll use PICWave's time domain simulation to calculate the impulse response of a laser, both the amplitude, AM, and frequency, FM. So the model we have open in front of us is a very simple Fabry Perot. Clicking on the cavity in the center here allows us to check the length, 160 microns, and it's referring to a cross-section called waveguide RWG, which on the left side, if we double click, we can open and just have a look, and it's a ridge waveguide structure. The current drive is defined to be an impulse with these settings. And then we can open the TD/TW calculator to do the calculation in the time domain for 20 nanoseconds. When that's completed, we can click the Inspect button. And we can go to the Spectra tab, plot the AM type, right-hand side monitor relative to current drive, display results in dB for a range of 30 dB with a max of 30,000 megahertz, let's say. So there's the AM response with a peak at around 2 gigahertz, and the FM response looks like this. Now this calculation was done with the Fabry Perot already in the steady state, and this was set on the Control tab by defining an initial state file. And just as a reminder, the current drive had a bias of 25 milliamps. So let's do the same simulation again, but for 50 milliamps. So I have a second model set up here with a 50 milliamp current drive. Run the calculation, inspect, Spectra, AM. So there's the AM response and the FM response for the higher bias. And you should see that the resonant peak and the 3 dB width has increased accordingly.